Hey, welcome to today's Lucky Learners tutorial. I'm Chibuzo, and I'll be showing you today how to find the LCM of two or more numbers using prime factorization. Now, I'm kind of excited about doing this, although it may not come across as such in my voice. Reason being, it's a nice way to show an application of decomposing numbers into products of their prime factors. Yeah, it's a very nice way of showing that application. Okay, starting with 12. What I'm now going to do is I'm going to express or decompose 12 into a product of its prime factors. So what we look to do is to find two numbers that will multiply themselves to give me 12. The first two numbers that jump to mind is 3 and the 4. Okay, I could have gone with 2 and a 6, but 3 and the 4 was what first jumped to mind. Each time I come to a prime factor in that decomposition tree, I underline it twice and I stopped decomposing. So because 3 is a prime factor of 12, I will stop there. With 4, I continue to decompose, and that would give me 2 and 2. Prime factor, and I'll stop there. So in index notation, this would be 2 squared times 3. 2 squared is 4, 4 times 3 is 12. I've now expressed 12 as a product of its prime factor. I'm not really going too much into the maths here because we should know this at this stage already. This tutorial is really just focusing on how to find the LCM using prime factorization. So I'm assuming you already know how to decompose numbers into products of their prime factors. Okay, moving on to 32. Okay, 16 and 2 jump to mind. So 16, 2. Again, I've hit a prime factor. So as far as that tree is concerned, I'll stop decomposing on that branch. Moving to 16, 4 and 4 first jump to mind. Now, both 4 and 4 obviously are not prime factors, so I can decompose them further. Hitting prime factors there and hitting more prime factors there. Instantly I see that will simplify to 2 to the power 5 in index notation. Okay, right, so how do I now use this to find the LCM of 12 and 32? Well, with 12, expressing 12 as a product of its prime factors in index notation gives me 2 squared times 3. And doing the same thing for 32, expressing 32 as a product of its prime factors in index notation gives me 2 to the power of 5. Now what I do is I look at the index notation for 12 and I look at the index notation for 32, and I simply circle, as far as the powers of 2 are concerned, the highest, which would give me 2 to the power of 5. Then I look at the index notation for 12 and I look at the index notation for 32, and I circle the index notation with the highest power of 3, which would be with 12. I then simply multiply the 2. 2 to the power of 5 is 32. Multiplied by 3. That can give me 96, which is the LCM of 12 and 32. thank you for having joined me for this Lucky Learners tutorial, and I look forward to seeing you again. Bye bye.